Section 3.4 is on direct variation. Direct variation is described by the equation y equals kx, where k is the constant of variation. The constant of variation is also known as the slope of a line. So here's an example. It says name the constant of variation for the equation and then find the slope. So we have a pink line here, and the arrow going to it says that the equation of this line is y equals 1/2 x. Recall that the formula for direct variation is y equals kx. So in this case, k is equal to 1/2. Notice it's the number in front of x. So that's my constant of variation. Okay. We also said that the constant of variation is the same thing as the slope. So the slope of this line is also going to be 1/2. And just in case you're not sure of that, let's go ahead and use the slope formula here. So let's subtract our y's. So I have 3 minus 0. Subtract our x's. Oops. I have 6 minus 0, which gives me 3 over 6, which is 1/2. So the constant of variation of this line, of the equation, is 1/2. The slope of the line is also 1/2. Graphs of direct variation functions always pass through the origin. That is, they always pass through the point 0, 0. Therefore, the x and y intercepts are both 0. So you can't graph a direct variation function by using x and y intercepts. To graph it, we actually need to use the slope. So y equals 3/4 x is a direct variation function. Okay, and notice that the slope of this line is 3/4. It's the number in front of x. It's the constant of variation. Recall that slope means the change in y. In other words, how much is the rise over the change in x, or how much is the run. So a slope of 3/4 means that we go up 3, okay, because the 3 is positive, and that's the y direction, up, down. And the 4 means that we go right 4, because the 4 is positive, we're going to go to the right 4 spaces, in the x direction, that is. So notice you can also write 3/4 as a -3 over a -4, because a negative divided by a negative gives you a positive. If we were to translate this into how to move on our graph, that's going to mean we go down 3, because negative is down, and my bottom number tells me left or right, and since it's negative, I'm going to go left 4. Actually, M doesn't stand for move, but I kind of think it's helpful to remember how to graph. Remember, a direct variation function always starts at 0, 0, and now we're going to use our slope to move from that point. So I'll go up 3 and right 4 and graph a point, and actually from that point I could continue going up 3 and right 4. Then I can use my slope that has 2 negatives in it and go down 3 and left 4, and from that point I could continue going down 3 and left 4. Although minimum I'd like to see is the origin, oops, and then the 2 points on either side. So let's connect those, and that gives me the graph of the direct variation function y equals 3/4 x. Let's take a look at another example like this. Here we have a constant of variation and a slope of -2. Let me move that down a little bit further. So my slope is -2. So I can write that as a -2 over a +1, or a +2 over a -1. And I'm going to use this to tell me how to move from my starting point, which is the origin. So a -2 on top means I'm going to go down 2, because that's my change in the y direction. That's going to be up or down. And a +1 on the bottom tells me I'm going to go right 1 unit. Your number on top is always up or down. Your number on the bottom is always left or right. So now if I put my -1 on the bottom, that's going to tell me on the top to go up 2, and on the bottom I'm going to go left 1. So let's go ahead and graph this. Starting at the origin here, I'm going to go down 2 and right 1, Going back to the origin, I'm going to go up 2 and left 1. And you could continue to go from this point down 2, right 1, down 2, right 1, or from this point here up 2, left 1, up 2, left 1. But I'm okay if you just do the origin and then 1 point on either side. So that's the graph of the line y equals negative 2x. And here's the last type of problem we're going to take a look at. And it says, suppose y varies directly as x. As soon as I hear that, I'm going to think, that's my direct variation equation, y equals kx. I need to write a direct variation equation and then solve. So it says, if y equals 15 when x equals 12, find y when x equals 32. So I really have to do two things here. First thing I need to do is to write a direct variation equation. And to do that, I'm going to use this information right here. Y is 15 when x is 12. And I'm going to use that to find what is my constant of variation. So when y is 15, I don't know what my k is, but I do know that x is 12. So let's use that to find k. Divide both sides by 12. So k equals 15 over 12, which reduces to, dividing top and bottom by 3, 5 over 4. So my direct variation equation is y equals 5 over 4x. That's my direct variation equation, and that's the first part of the answer. Oops, nope, direct variation equation. Okay, now I'm going to use that equation to do the second part of the problem, which is this right here. It says find y when x equals 32. To do that, I'm going to use that equation, y equals 5/4 x. And I need to find y, so I don't know what that is, but I do know that x is 32. Okay, so y is equal to 5 over 4 times 32 over 1. Go ahead and do some canceling. Both of those are divisible by 4. So y is equal to 5 times 8, which is 40. And that's the second part of the problem. Notice it said to do two things. Write a direct variation equation, which we did here, y equals 5/4 x, and then solve, which was finding y when x equals 32. So in this lesson we took a look at direct variation equations and used the formula y equals kx to graph lines and to solve direct variation equations.